Thank you, Khalid. Do you see my screen well?
Yes.
Yeah, okay. So now we continue directly on oxygenation of the newborn. This is a favorite topic of mine. I've been involved in this for more than 40 years. And here's an outline of my lecture. I will say a few words about oxen and oxen toxicity, and then I will go through with you the data we have for resuscitation, how much oxen we should give, and also which oxen saturation targets we should aim at the first minutes after birth. And if there is time, I will say a few words about oxygenation in immature infants beyond the delivery room. So here's my disclosures again. And for those of you who are interested, I have, together with my collaborators, written several articles the last year. This is a review article in Pediatric Research about oxygen therapy of the newborn. We call it From Molecular Understanding to Clinical Practice. Here's an article we published in Free Radical Biology and Medicine. It's more about oxidative stress in the newborn period. Max Vento and I, we published this article about how we should target oxygen immediately after birth. And very recently, this study about oxygen metabolism was published. It was in April. I will recommend the whole issue of the April issue of seminars in fetal and neonatal medicine, because it's dedicated to oxygenation of the newborn. And just a few days ago, we published this article in Journal Pediatrics about optimizing oxygenation of the extremely premature infant during the first few minutes of life. Should we start low or should we start high? And I think that is one of the hot questions in this field presently. I'll come back to that at the end of my lecture. So, what are the goals of our oxygen therapy? Well, of course, it's first of all to provide sufficient oxygen to the tissues and avoid anaerobic metabolism. It's to prevent hypoxic pulmonary vasoconstriction, to promote brain and somatic growth, and as every neonatologist knows, we try to minimize adverse effects of oxygenation. And that leads me to this issue, the dichotomy of oxen. We know that oxygen is critical to life, but we also know that too much oxygen can cause oxidative stress, lung injury, and diseases, bronchopulmonary dysplasia, also other conditions. ROP seems to be affected by the oxygenation, brain damage, impaired brain development, and so forth. So we have to find a correct balance, and that I've been working with that for 40 years. And I don't think we still have that balance. We don't know the balance. Yeah, and we also know that oxidative stress may injure other organs as the heart and the kidney, other vital organs. So this is just a very brief recapitulation of the biochemistry, why we need oxygen, and what is happening. So if we go here we are in the mitochondria, where we have oxidative phosphorylation is happening. There are 5 complexes here where we have the electron transport, and when the electrons are transported from one complex to the other, protons are pumped over the inner mitochondrial membrane, and they're generating a gradient, and this gradient can be utilized to produce ATP. So here, and then what happens here is that oxygen accepts the electrons at the end of the electron transport and generates water. So that's the purpose of oxygen. It's an electron acceptor here. We know that some of the electrons here, they leak out and they react with oxygen and generate reactive oxygen species, RS, and fortunately they can be neutralized by antioxidants and antioxidant enzymes. Now, during hyperoxia, more free radicals are generated, and surprisingly, less ATP is generated. I will show you some data at the end of my lecture. So, reactive oxygen species, they damage a number of macromolecules as DNA, proteins, lipids, and carbohydrates. I'll not spend more time on that. I will go directly to the clinical issues and start out with newborn resuscitation. How much oxygen should we give to term and preterm babies during resuscitation? Well, you know, traditionally, neonatologists have used a lot of oxygen in the delivery room. And the question is, why? Why did pediatricians and neonatologists love oxygen? I think we have to go back to some of our basic literature. This is Virginia Apgar's first article in 1953 regarding the Apgar score. You know that in order to get an Apgar score of 9 or 10, the baby has to be pink. And there's only one way to make a newborn baby pink, the first minutes after birth, and that is to give oxygen. And that was what happened many places in the world. In South America, for instance, it was routine to give every newborn baby a dash of oxygen to pink them up to get a high Apgar score. And in fact, Virginia Apgar and her peers 60 years ago, soon 60 years ago, they used a lot of oxygen. 20% of her original population cohort were given oxygen by some mean or the other. So there was a competition to get as high Apgar score as possible. And today we know that this was not very fortunate, I think. Just a very brief recapitulation of the transition. We know that in fetal life, the fetus is hypoxemic, a low PO2, saturation between 50 and 65%. And then when the baby is born and during the normal transition, the pulmonary hypertension resolves and there's a gradual improvement in oxygen saturation. So cyanosis is normal during fetal life and for the first few minutes after birth. So it's probably not possible to get an Apgar score of 9 or 10 the first minute of life without giving oxygen. When you look at how the saturation develops in normal babies, you can see here that at 2 minutes, this is preductal values, the mean value is just above 70, and you see the wide variation. And even at 5 minutes here, that many of these babies have saturations less than 80. So that is the situation. And maybe the reason that oxygen was given to so many babies from the 50s and 60s and onwards. What happens if you give 100% oxygen? Well, we have several clinical studies, but also animal studies showing that you get enormous PO2 peak. This is from a study in Sweden by Linner and co-workers, where they made newborn lambs asphyctic by clamping the cord. And when they got cardiac arrest, they randomized the lambs to be resuscitated with 100% or 21% oxygen. You see the red line here is represents the PO2 when, see the pointer is, well, yeah, the pointer, here it is. The PO2 increased to very high levels. By contrast, if you give room air, you see there's a slow increase and normalization of the PO2. Even in the brain, you get this enormous peak in brain tissue PO2 with 100% oxygen compared with air, and also the saturation. You get the same big differences. Even a 3-minute exposure to 100% oxygen gives this very high peak compared with room air. So before 1998, the world map regarding the use of oxygen for newborn resuscitation looked something like this. All guidelines recommended to use 100% oxygen. I didn't know exactly what they did in Africa and some of these countries, but basically every guideline said use 100% oxygen. If you don't have oxygen, you shouldn't start ventilation. It was even believed at that time. So for those babies at that time, before 1998, who were resuscitated, they had this enormous PO2 peak. But then in the 90s, we carried out 2 clinical studies where we randomized term and near-term infants to be resuscitated with air or 100% oxygen. And here is a meta-analysis we published in 2008. At that time, there were 10 studies, including more than 2,000 babies, where the babies had been randomized to air or 100% oxygen. And what we found was that there was a 30% reduction in mortality if you start with air instead of 100% oxygen. So the world map started to change, and in 2006, actually, Canada was the first country which switched from 100% oxygen to air. And then Australia, some months later, came after, and then Finland, Sweden, Russia, UK, the Netherlands, Spain, they switched to air. Some countries, including my own, they were a little bit more hesitant and said, well, we choose something in between, 40% for instance. The most conservative were the Americans. They didn't change at that time. So during this period, some babies got this very high PO2 peak and others got a more physiological treatment. But in 2010, ILCOR changed the guidelines and recommended that in term infants receiving resuscitation at birth with positive pressure ventilation, it is best to begin with air rather than 100% oxygen. So then now the world map changed like that, not from one day to the other, but after some time, I think now all guidelines recommend to start with air for term and near-term infants, and we have this more physiological approach. So we try to illustrate what's happening if we give air versus 100% oxygen. So here is the PO2. It is normalized slowly, but it's not too high. Some free radicals are generated for sure. By contrast, if you give 100% oxygen, you get this enormous peak, PO2 peak, and you get this wave of free radical generation. And this affects the child with cerebral vasoconstriction, brain inflammation, pulmonary vascular reactivity increases, and it's also been shown that you get damage to the heart and to the kidneys. And a high FiO2, the first 10 minutes of life, is also associated with the increased risk of childhood leukemia. Now, a year ago, a new meta-analysis was published, including most of the same babies as we included in our meta-analysis in 2008. This was from Welsford and co-workers. And fortunately, at least to my relief, they found more or less the same as we did, an almost 30% reduction in mortality if you start with air compared with 100% oxygen. And these authors said that there will unlikely be any further studies on this topic. I'm not sure about that. It could still be some subgroups we haven't studied in detail who might need some more oxygen during resuscitation. They also looked at hypoxic ischemic encephalopathy, grade 2 and 3, and there was no difference whether you start high or low, which I think is good to know, that you don't get more adverse effects by starting with air compared with 100% oxygen. And also when they looked at neurodevelopmental injury, there was no difference. There are only 2 studies. It's my own and a study from Bajaj in India. So we would have wished to have more data on this topic. So for term and near-term infants, if you start with air, you reduce brain inflammation and perhaps also hypoxic ischemic encephalopathy. Mortality is decreased, cardiac injury and also pulmonary hypertension is decreased, and renal injury and risk of leukemia. So there's not much discussion about that now. We start with air in these babies. But what about preterm infants? We know that preterm infants are different compared with term infants. I will not go into details because all of you know that, but just want to remind you that preterm babies, they react to hypoxia differently compared with term babies. They go into bradycardia right away, which might increase the risk of intraventricular hemorrhage. They have lowered defense against oxidative stress, and they have surfactant deficiency, of course, and they have, yeah. Oops. Yeah, and they have weaker muscles and so forth. So they're different compared to term infants. So what did the ILCOR recommend? Well, in 2010, when it changed from oxygen to air for term and near-term infants, they said that because many preterm babies less than 32 weeks gestation will not reach target saturations in air, blended oxygen and air may be given judiciously and ideally guided by pulse oximetry. Now, ILCOR didn't mention which FiO2 you should start out with, and that was probably quite smart because at that time I think we didn't know. But in 2015, they changed the wording a little bit, and now they recommended against initiating resuscitation of preterm newborns less than 35 weeks with high supplementary oxygen concentrations, that is 65 to 100%. And for babies, yeah, they didn't say probably less than 35 weeks, but they don't specify that. But they recommend initiating resuscitation with a low oxygen concentration, 21 to 30%. So that is ILCOR 2015. What does the European recommendations say? They say that oxygen should be controlled by using a blender, and initial FiO2 of 30% is appropriate for babies less than 28 weeks and 21 to 30% for those between 28 and 31 weeks. Adjustment should be done guided by pulse oximetry. So what is the evidence for such recommendations? The question is, of course, should we start low and titrate down, or should we start high, start low and titrate up and start high and titrate down? One of the first studies in this field was published by Max Vento's group in Spain. And here they randomized babies less than 29 weeks in the delivery room to 30% or 90% oxygen if they needed ventilation. What you see here is that there is absolutely no difference in the saturation between these groups. And the reason for that is perhaps that there is a difference in FiO2 only 3-4 minutes because FiO2 was adjusted very quickly. No difference in heart rate, but I don't have those data here. But what I found was that there was more oxidative stress and also more inflammation in the babies who started out with a 90%, although the FiO2 was higher only for a few minutes. So then the Torpedo Trial was published, and this is a study we carried out with the basis from Australia. I think also some Gulf countries participated in this study. And babies less than 32 weeks were randomized to air or 100% oxygen in the delivery room if they needed positive pressure ventilation. And what we couldn't find any difference in mortality when we looked at the whole cohort. However, when we did a post hoc analysis of babies less than 28 weeks, to our surprise, and I would say also concern, we found a almost fourfold increased risk of mortality in those who had been started with air. So the smallest babies started with air had a higher mortality. When we looked at primary outcome, which was death or disability, we also found that those babies who had reached a saturation of 80% or more within 5 minutes had a significantly reduced primary outcome, 50% reduction, as you can see here. So this was, of course, exciting. So we carried out updated review and meta-analysis, and we looked at studies where preterm babies had been randomized to receive a high FO2, which we defined as 60 to 100%, versus a low FO2 defined as 21 to 30% oxen. We were able to find 8 studies, which we included in the meta-analysis. And what we found here for mortality, when we looked at all the babies, upper panel here, it was that there was absolutely no difference in mortality, whether you start high or low. But then we split the data up in masked studies and unmasked studies. And for masked studies, there was an advantage to start low. But for unmasked studies, there was an advantage to start high. So this is, of course, a little bit confusing, and we don't have the solution of this yet, but we know that the masked studies are the most recent ones, when we started to titrate more carefully according to pulse oximetry and so forth. So it might be that it's still an advantage to start low in these smallest babies, but we don't know. But our results from the Torpedo Trial that led to a renewed interest in how saturation should develop optimally the first minutes after birth. And here, Max Venter and I, we have drawn a curve where we're trying to illustrate what we believe is the normal, whatever that is for babies less than 29 weeks, the normal increase in saturation the first minutes after birth. And it starts at 2 minutes, median values and 2 standard deviations. And you see here that the median value is around 50. At 5 minutes, it's 65. And it takes another 5 minutes maybe to reach about 80%. Now, when you're talking about how the saturation should develop, we had to be aware that it also depends on other factors. For instance, whether or not you are using a PEEP. If you're ventilating with a T-piece device, the saturation increases faster than if you just use bag and mask without a PEEP. And there's also a gender difference. Girls have a more rapid increase in saturation compared with boys, probably because their lungs are more mature than boys. And we also know now know that cord clamping affects how the saturation develops. This is from a study from Nepal, babies about 33 weeks, but it shows that saturation is higher after delayed cord clamping, which I think is an important observation. Now, we have been able to identify 707 infants less than 32 weeks, which have been included in studies in the delivery room, given high or low oxygen saturation. We found four groups: those who had started with air, those who started with 30% oxygen, 60 to 65%, and 90 to 100%. And we also split the material up in babies less than 29 weeks and 29 weeks or more. And then we made these graphs of how the saturation develops the first 10 minutes after birth, according to which FO2 we started out with. And here we have babies about 29 weeks. Now the shaded area here is the recommended target by American Heart Association, and these circles are targets from the European Resuscitation Council. Now we don't know if these recommended targets are optimal because they are not evidence-based. They're basically based on our results. But what you see here is that for babies about 29 weeks, they are above or close to the target almost immediately after birth. The only exception is the babies given room air. It takes 6 minutes to reach target. For babies less than 29 weeks, the situation is different. Now it's only those who received 90 to 100% who reach target within 2-3 minutes. All the other groups, it takes 6, 7, maybe 8 minutes to reach target. Now we don't know if this is bad or good, but I think it's an interesting observation. Now everybody knows that it's not easy to reach the target. Here we have the Dawson curves, the 25th to the 50th percentile, which we think we should be a target, but it's not evidence-based, but that's what we suggest. And here is a baby, it's above the target, then we decrease the FO2 10%, then the baby is within target for some seconds, then it's under, so we increase FO2 another 10% up, still under target, and we increase another 10%, and then after almost 5 minutes, the baby is within target. So it's not easy to reach the target. When we did a follow-up of the torpedo babies, what we found was that cognitive score was significantly higher in those babies who had reached a saturation of 80 or more within 5 minutes. You see there's more than a 5-point difference. So then we started to think that maybe it is important to aim at a saturation of 80%, at least 80% within 5 minutes. There was also a higher mortality rate for those babies who didn't reach the saturation target of 80, and also more severe intraventricular hemorrhage, but there was no effect on BPD. So then again, the same question, should we start with a low FO2 and titrate up, or start high and titrate down? Well, that is not easy. If you start low, and this is a study recently published from Austria, showing how the saturation develops in babies who did not reach a saturation target of 80% versus those who reached a saturation of 80%. And here we have the heart rate. And what you see here is that, for instance, at 3 minutes, is 2 minutes, 3 minutes, well, there's significant differences, but you know, if you're in the delivery room, it's not big differences between these groups. It's very hard for the clinician. I think it's impossible to, from a saturation value at 2 or 3 minutes, to say this baby will reach a target of 80% within 5 minutes or not. And when you look at FO2 in these two groups, you see it's even more difficult because there's no difference in FO2 the first 3-4 minutes between the groups. So for that reason, several colleagues will say, well, it's better to start high and titrate down, because then we are sure that we reach this target of 80%. One argument for that comes from a study carried out in Melbourne, Australia, in newborn kittens. It was done by Arjen de Paas, who is now in the Netherlands, and Stuart Hooper in Melbourne. So what they did in these immature kittens, they recorded the breathing rate when they were given air after birth. Then they were switched to oxygen. You see breathing rate increased. Then back to oxygen, then back to, not back to air, but here is nitrogen, then breathing rate goes down. They also measured the time the glottis was open, and they found that, well, it's increasing here also with air, but when they gave oxygen, the glottis was open longer than when the animals were ventilated with air. Very recently, Dekker and co-workers from the same group, now from the Netherlands, studied newborn babies 30 weeks or less. And what they found was that they had one group started with 30% oxygen and one group starting with 100% oxygen. And then they titrated up or down according to this algorithm here. What they found was that the babies started high here. Well, of course, they were more pink. They had a higher minute volume, shorter duration of mask ventilation. They had a higher oxygenation at 5 minutes, shorter duration of hypoxemia, but they had a higher FiO2 exposure during the first minute. When they looked at the total outcome, there was no difference in duration of hyperoxemia, and there was no difference in oxidative stress markers, but they had a very short follow-up in this study. So these authors would argue that you should start high and titrate down. But of course, you should keep the oxygen high, as short, as brief as possible. Well, before I continue, I would like to remind you why oxygen is so toxic in the newborn, especially the preterm baby. They have a reduced protection against oxidative stress. Oxidative phosphorylation is reduced. Hyperoxia increases inflammation, and DNA protection and repair are downregulated. Cell growth is affected. This is a study, one of our studies from newborn mice, hypoxic newborn mice, and we resuscitated them with different oxygen concentrations, 21%, 40%, 60%, and 100%. And what we found in the brain is that there was a downregulation of oxidative phosphorylation. Those animals who received 60 or 100% oxygen. So in all the 5 complexes of oxidative phosphorylation, there was a downregulation of genes, as illustrated here, which means that ATP production is probably reduced when you resuscitate with a hyperoxic gas mixture. I also want to remind you that hyperoxia leads to epigenetic changes. I don't have time to show you these data. So what we recommend, and we just published these recommendations, people may argue with us and disagree with us, but we think that if you give supplemental oxygen, even very brief in immature babies, it leads to increased oxidative stress, inflammation, genomic changes, reduced DNA repair, and cell growth inhibition, also long-term epigenetic changes. Still, oxygen may be needed in the most immature infants, those less than 28 weeks, but it should be given as low and brief as possible. So we still think that we should start low, 30% oxygen, and titrate up according to the saturation and the clinical response, and heart rate is the best way to evaluate the response. But it's clear that we don't know what is the optimal starting initial FiO2 in these babies. For that reason, we are planning a new study, a new Torpedo Trial we call Torpedo 3060, where we want to randomize babies less than 29 weeks to 30% oxygen or 60% oxygen. And we still are interested in recruiting units. So if any one of you are interested in joining, please contact me or Rebecca Brown at the email as shown here. And then I have a few minutes left, I hope. Is that correct, Chairman? Yeah. Yeah. So yes, yes, sir. Yeah. So I just finished very briefly with with how we should oxygenate extremely low birth weight infants beyond the delivery room. And then I, of course, refer to the NEOPROM studies, the trials. And the question these trials asked was, what is the optimal target saturation for preterm neonates that would result in the lowest death and neurodisability? So there are 5 studies: the surfactant, positive pressure, and oxygenation randomized trial, the support trial in the US, the Canadian oxygen trial from Canada, and the benefits of oxygen saturation targeting, the Boost 2 trials from UK, New Zealand, and Australia. So babies less than 28 weeks were randomized before 24 hours of age to a low saturation target, 85 to 89%, or a high saturation target, 91 to 95%. It was a big study, almost 5,000 babies included. And what was found was that there was more necrotizing enterocolitis in the low saturation target. There was also more mortality, but there were more ROP in the high saturation target. Now, in 2010, guidelines, at least the European guidelines, said that oxygen saturation target should be between 85 to 93. Based on the NEOPROM studies, guidelines changed, both the European guidelines and American Academy of Pediatrics. So now saying that target should be between 90 and 95 or 90 to 94 based on this. Here is a meta-analysis I carried out, published some years ago now, showing the mortality. And you see that all these meta-analyses, the 3, show that there is an increased mortality in the low saturation arm. On the other hand, there's less ROP, severe ROP, not more blindness. So no effect on intraventricular hemorrhage, and no effect on BPD, but necrotizing enterocolitis was higher in the low saturation target. So then I looked at the risk difference between the 2 study groups, and here we have some outcome variables, and above this line means that it favors a high saturation target, and under it favors a low saturation target. So, and here we have the p-values, and see for mortality, there is a significant difference between the groups. It's higher mortality in the low saturation groups, and also for necrotizing enterocolitis, I said. ROP is the opposite, and also BPD. However, when BPD was defined physiologically, we didn't find any significant difference. So oxygen targets between 91 to 95% increase ROP in need of therapy, but not severe vision, not more blindness, fortunately. Targets between 85 and 89% increase mortality and necrotizing enterocolitis. So you have to find the right balance. Long-term follow-up didn't show any differences between these 2 arms regarding death, disability, blindness, hearing loss, blood pressure. Yeah, hyperoxia may lead to epigenetic change in the lung. We don't know if these are long-lasting or transient. So this was very brief about the NEOPROMs. I could say much more about that, but the time doesn't permit. So I just want to summarize. I think that today we are able to individualize our oxygen therapy much more than just a few years ago. In the delivery room, for babies about 31 weeks, we should still start with air. 21 to 31 weeks, start with air or 30% oxygen. I think most of us would say start with 30% oxygen. Less than 28 weeks, they absolutely need some oxygen. We don't know what is optimal, so we have recommended 30% oxygen, but it might be 40%. which is maybe even higher, is the optimal for these babies. And we need more research in this field. For all gestation ages, adjust according to saturation. And we think that we should start low and titrate up. We need randomized studies to test the significance of saturations above 80% or lower than 80%, the first 5 minutes of age, and how it should be adjusted. But it's not easy to do such randomized studies. And in the future, we have to individualize according to gender, whether or not we're using CPAP or PEEP, cord clamping. Beyond 28 weeks, target saturation between 91 to 95 or 90 to 94%, as we recommend in Europe, because we don't want to have too high alarm limits. We have put very tight alarm limits. The first recommendations are from American Academy of Pediatrics, and the second from the European recommendation. You see the very tight alarm limits. And of course, that is very difficult for the nurses to keep that. But we want to emphasize that we don't want fluctuations, and we don't want saturation to increase to too high levels. It should preferably not be higher than 95 to 96%. So with this, I would like to close and thank my collaborators.